Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Welcome everyone. Today we're delving into DeepSeek Roan, a groundbreaking AI model that leverages reinforcement learning to master reasoning. This innovative approach empowers AI with the ability to learn and improve, like a child learning to ride a bike. As we explore DeepSeek Roan's journey, we'll uncover its potential to redefine the future of AI. Can you explain the significance of integrating reinforcement learning into the training of large language models, particularly in the context of enhancing their reasoning capabilities?
Integrating reinforcement learning into the training of large language models is like teaching a child to ride a bike. At first, the child needs guidance and support, but as they gain experience, they learn how to balance and pedal on their own. In the context of these language models, the initial training phase is like the child learning the basics of biking. This is where they are fine-tuned to understand language. The next step, using reinforcement learning, is akin to letting the child practice riding without training wheels, but with rewards and encouragement for maintaining balance and speed. During this stage, the model focuses on enhancing its reasoning skills in various tasks, such as solving math problems or coding. However, a challenge arises when the model has to deal with multiple languages, which can be like the child getting confused by different bike paths. To help with this, a language consistency reward is introduced, encouraging the model to stick to one language, promoting clarity and better understanding. Even though this might make the model seem a little less effective at first, like a child wobbling while learning, it ultimately leads to better performance and clearer communication. By the end of this training process, the model becomes more adept at reasoning, just as the child becomes a skilled bike rider, able to tackle complex paths with confidence. In short, using reinforcement learning helps large language models learn to think and reason more effectively, similar to how practice and encouragement help a child master riding a bike.
Could you elaborate on the specific methodologies employed in DeepSeek Roan's multi-stage training process and how they contribute to the model's ability to outperform existing models in reasoning tasks?
The training process for DeepSeek Roan consists of several stages, each designed like steps in a recipe to create a delicious cake, with each step adding unique flavors that improve the final product. In the first stage, cold start data and initial fine-tuning, the model begins by learning from a carefully chosen set of high-quality examples. Imagine teaching a child how to write stories by showing them beautiful books. First sight. This helps the model understand how to generate clear and readable output right from the beginning. The second stage involves reasoning-oriented reinforcement learning. Here, the model takes what it learned in the first step and practices reasoning skills in various tasks like coding or solving math problems. However, a challenge arises because the model encounters different languages, making it a bit like a child trying to understand instructions in multiple languages at once. To tackle this, a language consistency reward is introduced, encouraging the model to stick to one language during its reasoning process. Although this may cause a slight drop in its overall performance, it greatly enhances the clarity and consistency of its responses, much like how practicing one language helps a child become more fluent. The third stage shifts focus to rejection sampling and supervised fine-tuning. Here, the model learns to refine its skills further by integrating feedback, similar to a student revising their work after receiving comments from a teacher. This helps to ensure that the model not only reasons well, but also communicates its thoughts clearly, making it user-friendly. By following this carefully constructed multi-stage training pipeline, DeepSeek Roan not only improves its reasoning abilities, but also manages to outperform existing models in reasoning tasks. Each stage builds upon the previous one, like layers of a cake, leading to a final model that is both smart and easy to understand. This innovative approach allows DeepSeek Roan to showcase remarkable reasoning capabilities, even learning to self-correct and think deeper when faced with more complex problems.
What findings or results did DeepSeek-Rhone demonstrate in comparison to OpenAI's OON series models, particularly regarding its performance on reasoning tasks?
DeepSeek-Rhone demonstrated impressive results when compared to OpenAI's OON series models, particularly in reasoning tasks. It was found that DeepSeek-Rhone not only matched but often surpassed the performance of models like GPT-4 Woon. This is akin to a high school student outperforming college students on a math test, while also requiring less effort and resources to achieve those results. Additionally, DeepSeek-Rhone's smaller versions, such as DeepSeek-Rhone 32B and DeepSeek-Rhone 70B, outperformed OpenAI OON Mini in most benchmarks. This indicates that the techniques used in DeepSeek-Rhone's training, especially distillation, the process of transferring learned reasoning abilities, were very effective. In a more in-depth comparison, another model trained purely through reinforcement learning, known as DeepSeek-Rhone 0-32B, achieved performance similar to a larger, more established model after extensive training. However, when comparing distilled models, the distilled version, DeepSeek-Rhone Distill QN 32B, significantly outperformed its RL-trained counterpart. Overall, the findings suggest that DeepSeek-Rhone represents a fundamental shift in the development of AI, moving beyond just recognizing patterns to actively reasoning and solving problems in a way that resembles human thought processes.
What implications do the results of DeepSeek-Rhone's training and performance have for the future direction of AI research and the development of reasoning-capable language models?
The results of DeepSeek-Rhone's training and performance have significant implications for the future direction of AI research and the development of reasoning-capable language models. Firstly, the success of DeepSeek-Rhone suggests that it is possible to enhance reasoning capabilities through structured training methodologies, rather than relying solely on increasing the size of models. This approach challenges the traditional mindset in AI, which often prioritized scaling up models without a focused strategy for improving reasoning. It indicates that intentional multi-stage training processes can lead to better outcomes in reasoning tasks, offering a new blueprint for future AI systems. Secondly, the integration of high-quality data in the early stages of training serves as an important lesson. Just like giving a young student good examples to follow can guide their learning effectively. This method highlights the value of starting with well-curated information to shape a model's understanding from the outset. This could lead researchers to explore how different types of guiding data can positively impact AI learning. Additionally, the emphasis on language consistency and readability demonstrates that making AI more user-friendly is just as important as enhancing its reasoning skills. This focus on clear communication means that future models can be developed not only to think better, but also to express those thoughts in ways that are easy for people to understand. Overall, the achievements of DeepSeek-Rhone mark a shift toward building more robust and intelligent AI systems that can actively reason, rather than merely process information. This could pave the way for advancements in various fields, from coding and mathematics to everyday conversational AI, ultimately making technology more accessible and effective for users.
How does the approach of using reinforcement learning in DeepSeek-Rhone compare to other traditional training methods, particularly in terms of efficiency and effectiveness in developing reasoning skills?
The approach of using reinforcement learning, RL, in DeepSeek-Rhone presents a significant contrast to traditional training methods, particularly in terms of efficiency and effectiveness in developing reasoning skills. Traditional methods, like chain of thought, prompting, and supervised fine-tuning, often focus on teaching models how to express reasoning through specific examples. It's similar to giving a student a textbook and asking them to memorize solutions without truly understanding the underlying concepts. While these methods can show some success, they tend to fall short in cultivating a deep, adaptable reasoning ability within the model itself. In contrast, Reinforcement learning encourages the model to learn reasoning more organically, much like a child learns through exploration and rewards. In the case of DeepSeek Roan, the model engages in a large-scale training process where it tackles various reasoning tasks. If it makes progress, it receives rewards, which incentivizes the model to refine its reasoning abilities. This approach not only fosters a deeper understanding, but also allows the model to adapt and improve over time, as it learns from both successes and failures. While traditional methods might yield immediate results, they can lack the fundamental reasoning skills needed for complex tasks. Meanwhile, the RL approach in DeepSeek Roan enables a direct incentive for the behaviors associated with effective reasoning, resulting in a more capable and flexible model. Thus, the methodology used in DeepSeek Roan not only sets a new standard for efficiency in training, but also enhances the effectiveness of developing reasoning skills, positioning it as a promising direction for future AI research and development.
What are some of the key challenges and limitations faced when implementing reinforcement learning techniques in the training of large language models like DeepSeek Roan?
When implementing reinforcement learning techniques in the training of large language models like DeepSeek Roan, several key challenges and limitations arise. One significant challenge is language mixing within chain-of-thought reasoning. This occurs when the model has to process and reason in multiple languages at the same time. To address this issue, DeepSeek Roan introduced a language consistency reward, which encourages the model to use a consistent language throughout its reasoning. While this approach improved clarity and readability, it may also lead to a slight dip in overall performance on standard benchmarks, highlighting the trade-offs involved in balancing consistency with raw performance. Another limitation is the complexity of designing effective reward signal. The final reward signal for DeepSeek Roan combined accuracy with language consistency, but finding the right balance between different types of rewards can be tricky. If the rewards are not well calibrated, the model may struggle to learn effectively, or might focus on optimizing for one aspect at the expense of another. Furthermore, the RL training process can be resource-intensive and time-consuming. It requires continuous interaction with the environment, in this case, reasoning tasks, and extensive iterations to converge on effective reasoning strategies. This can demand significant computational resources, which may not always be feasible. Lastly, there may be challenges related to the model's ability to generalize its reasoning skills across different tasks. While the training can enhance reasoning abilities in specific areas like coding or math, ensuring that the model can apply its reasoning effectively in a broader context remains a complex task. Overall, while reinforcement learning offers promising advantages for developing reasoning skills in language models, addressing these challenges is crucial for maximizing its effectiveness and efficiency in practice.
How does the distillation process in DeepSeek Roan contribute to its overall performance and reasoning capabilities, particularly in comparison to other models that do not utilize this technique?
The distillation process in DeepSeek Roan plays a crucial role in enhancing its overall performance and reasoning capabilities, particularly when compared to models that do not utilize this technique. Distillation involves transferring knowledge from a larger teacher model, which in this case is DeepSeek Roan, to smaller student model. This process is highly efficient, as it allows smaller models to inherit the powerful reasoning capabilities developed by the larger model, without needing to train from scratch. Imagine a talented chef teaching their recipes to a younger cook. The younger cook benefits from the chef's experience and knowledge, enabling them to create high-quality dishes more quickly and effectively. As a result of this distillation process, models like DeepSeek Roan 32B and DeepSeek Roan 70B significantly outperform other smaller models, such as OpenAI Mini, across various benchmarks. This showcases how effectively distillation can imbue smaller models with significant reasoning power that rivals larger counterparts. When comparing distilled models, such as DeepSeek Roan Distilled QN32B, to those trained purely through reinforcement learning, like DeepSeek Roan 0QN32B, the distilled model consistently shows superior performance across reasoning benchmarks. This indicates that the distilled models not only replicate the reasoning skills of the larger model, but also do so in a more accessible and efficient manner. In summary, the distillation process contributes to DeepSeek-Rhone's overall performance by enabling smaller models to leverage the advanced reasoning skills developed during the training of the larger model. This results in more efficient, powerful reasoning capabilities in a form that is more accessible for various applications, demonstrating a significant advantage over models that do not utilize this technique.
What future research directions or advancements do you foresee as a result of the findings from DeepSeek-Rhone, particularly concerning the development of more advanced reasoning capabilities in AI systems?
The findings from DeepSeek-Rhone open up several promising research directions and advancements for the future of AI, particularly in developing more advanced reasoning capability. One key direction is the exploration of multi-stage training processes. The success of DeepSeek-Rhone demonstrates that reasoning can be directly learned and refined through structured training, rather than just emerging from larger model sizes. This suggests that future research could focus on optimizing various stages of training to enhance reasoning skills in a more focused manner, potentially leading to even more sophisticated AI systems. Another area for advancement is the refinement of distillation techniques. As demonstrated, distillation efficiently transfers reasoning capabilities from larger models to smaller ones, making advanced AI more accessible. Future research could explore new methods of distillation that enhance this transfer process, possibly incorporating more diverse training data or innovative reward structures to further improve the reasoning abilities of distilled models. Additionally, there is potential for investigating the integration of reinforcement learning with other learning paradigms. While the current focus has been on RL, merging it with techniques like supervised learning or unsupervised learning could lead to hybrid models that possess robust reasoning skills and can adapt to various tasks more effectively. Furthermore, the ability of DeepSeek-Rhone to exhibit self-correction and reflection signals a shift toward developing AI systems that can engage in deeper, more human-like reasoning. Future research could delve into mechanisms that encourage models to reflect on their reasoning processes, allowing for continuous improvement and adaptability in complex scenarios. In summary, the findings from DeepSeek-Rhone provide a valuable blueprint for increasing the sophistication of reasoning in AI. By focusing on multi-stage training, refining distillation methods, exploring hybrid learning approaches, and encouraging self-reflection, the future of AI research could yield systems that not only reason, but do so in a manner that mirrors human cognitive abilities more closely.
Thank you all for joining us today. We've covered a fascinating topic, showcasing the groundbreaking advancements in language models through DeepSeek-Rhone. This large language model leverages reinforcement learning to enhance its reasoning capabilities, akin to a child learning to ride a bike. We learned about DeepSeek-Rhone's multi-stage training, employing language consistency rewards, which has significantly improved its reasoning accuracy and clarity. This model's performance surpasses existing models, demonstrating the potential of reinforcement learning for developing sophisticated reasoning skills in AI. Moreover, we discussed the practical application of distillation, enabling smaller models to inherit the reasoning abilities of larger ones. This breakthrough makes advanced AI more accessible and opens up exciting possibilities for future research. As we move forward, we'll explore optimizing multi-stage training, refining distillation techniques, and integrating reinforcement learning with other learning paradigms. Our ultimate goal is to foster self-reflection in AI systems, bringing us closer to creating truly intelligent and autonomous machines. Thank you again for being part of this thought-provoking conversation. We hope you'll continue to engage with us as we delve deeper into the exciting world of AI.